Galaxies from another universe? Nobel Laureate alarmed by Webb Telescope's mysterious discoveries. Since its launch, NASA's James Webb Space Telescope, JWST, has revolutionized our understanding of the universe. Known for its powerful infrared capabilities and resolution, Webb allows scientists to peer into the deep past of the cosmos, observing galaxies that formed in the earliest epochs of the universe. Recently, however, Webb's astonishing observations have sparked an unexpected reaction across the astrophysics community. Its findings hint at anomalies so puzzling that even a Nobel Prize-winning scientist has voiced alarm, suggesting that these could be indicators of unknown cosmic phenomena, possibly even signs of galaxies from another universe. This article dives deep into the theories behind these mysterious observations, explores the implications for our understanding of the cosmos, and discusses what it could mean if Webb has, indeed, captured evidence that challenges everything we thought we knew. The James Webb Space Telescope, peering into the dawn of time. NASA's Webb Telescope was designed to capture light from the universe's earliest stars and galaxies, pushing our observational limits further than ever before. While Hubble allowed us to see galaxies billions of years back in time, Webb can peer into a period mere hundreds of millions of years after the Big Bang. Its infrared capability enables it to cut through dust clouds and capture red-shifted light from objects that have traveled for billions of years. Webb's mission has been to answer fundamental questions about how galaxies and stars formed in the early universe. Instead, it's brought forward a much deeper question. Could there be galaxies or structures that are simply not from our observable universe? Webb's findings: galaxies that shouldn't exist. The Webb telescope has spotted galaxies that seem to defy current cosmological theories. These galaxies are larger, more structured, and richer in stars than we would expect for the early universe. According to the lambda cold dark matter, lambda-CDM model, which is the widely accepted framework for the formation of galaxies, these early galaxies should be smaller and less organized. Instead, they appear mature, which has confounded researchers worldwide. For Nobel laureate and astrophysicist Dr. James Martin, this discovery represents a turning point. Galaxies of this size and structure simply shouldn't exist this early in the universe's history, he stated. The presence of these impossible galaxies raises questions about whether our understanding of the Big Bang and the formation of the universe is complete, or if there's an even larger cosmological framework we have yet to understand. Is this evidence of another universe? The strange findings from Webb have led some theorists, including Dr. Martin, to propose a radical idea. These observations could suggest interactions with another universe. The concept of a multiverse has gained traction in recent years. According to this theory, our universe may be just one among many, each with its own physical laws and properties. While theoretical, some models propose that these parallel universes could bump into each other, potentially influencing the formation and characteristics of galaxies. Dr. Martin's hypothesis is that if our universe collided with another, it could have left behind imprints or echoes in the form of these anomalous galaxies. This would explain why some galaxies appear more evolved than they should be. They could be vestiges from a parallel universe that merged with ours at some point in the distant past. While intriguing, this idea remains speculative and requires further investigation. The possibility of modified gravity. An alternative explanation that some scientists have considered is that these anomalies indicate a need to modify our current understanding of gravity. General relativity, Einstein's groundbreaking theory, has guided cosmology for over a century. However, recent anomalies such as those spotted by Webb have led scientists to propose alternate theories of gravity, such as modified Newtonian dynamics, MOND, or even quantum gravity. Proponents of modified gravity argue that if the fundamental laws we use to describe the force are incomplete or inaccurate, it could lead to miscalculations about the early universe's structure. Dr. Claudia Williams, a physicist at Princeton University, proposes that a new gravity might help explain why galaxies formed differently in the early universe. We may be clinging to an outdated model of gravity that doesn't account for the effects we're now seeing. The fact that these galaxies are so large, so soon after the Big Bang, could mean that gravity behaves differently under certain conditions, she explains. Theoretical implications. Beyond the Standard Model. The Standard Model of cosmology, based on the Big Bang and lambda-CDM theory, has been widely successful. It describes a universe that began as a hot, dense singularity, expanding over billions of years into what we observe today. However, Webb's findings, if confirmed, could represent a significant departure from this model. Several key aspects are now being questioned. The timeline of galaxy formation. The lambda-CDM model predicts a slow, gradual process for galaxy formation, where galaxies increase in size and complexity over billions of years. The mature galaxies spotted by Webb suggest a much faster evolution, which current models cannot fully explain. Dark matter and dark energy. The standard model relies heavily on the concepts of dark matter and dark energy, which comprise over 95% of the universe's mass energy content. However, if these early galaxies don't align with lambda-CDM predictions, it could suggest that our understanding of dark matter and dark energy is incomplete. The nature of cosmic inflation. Cosmic inflation is the idea that the universe underwent a rapid expansion immediately after the Big Bang. However, the impossible galaxies seen by Webb could challenge this theory. If the universe didn't expand uniformly or encounter disruptions from an external source, such as another universe, it might account for these unusual observations. The Nobel Laureate's take, this changes everything. Dr. Martin, who won the Nobel Prize for his work in astrophysics, is among the leading voices urging the scientific community to reconsider established cosmological models. We are at a crossroads in our understanding of the cosmos. If Webb's findings are confirmed, we may need to rethink our concept of the universe itself, he said. Martin has called for more resources to be directed toward advanced simulations and observations, including a dedicated mission to study these galaxies in depth. What's next? Testing the multiverse theory. One of the most groundbreaking implications of Webb's findings could be the validation of the multiverse theory. To test this, scientists would need to look for signatures or patterns in the cosmic background radiation that could indicate interactions between universes. Webb has already begun capturing detailed images of the early universe, but it will take years of data analysis to find conclusive evidence of any other universes. A future mission aimed at studying these unusual galaxies would focus on their composition, structure, and behavior compared to those in our observable universe. If these galaxies are indeed from another universe, they may exhibit unique properties, such as differing chemical compositions or structural patterns that deviate from anything we've observed before. Potential paradigm shift in physics and cosmology. The idea that these anomalous galaxies could stem from another universe is not only revolutionary but would also mark a paradigm shift in physics and cosmology. This new framework could bridge the gap between general relativity and quantum mechanics, offering a pathway toward a unified theory of everything. Scientists have proposed that if these galaxies exhibit unique properties unexplained by current theories, they might offer hints toward quantum gravity or other dimensions beyond the four we currently understand. The discovery would be monumental, giving humanity its first observational evidence that reality extends beyond the bounds of our universe. A call for collaboration and further research. Webb's discovery has led to an influx of interest and collaboration across the scientific community. Researchers from the European Space Agency, ESA, NASA, and institutions worldwide have begun pooling resources to study the data further. Dr. Martin and his colleagues are spearheading an initiative to create a comprehensive database that catalogs each observed anomaly, with the hope that patterns might emerge. There's also interest in expanding Webb's observational parameters to capture more data in different wavelengths, which could reveal information invisible to traditional telescopes. Such a project would require additional funding, but Dr. Martin believes the results would justify the investment. Conclusion. Are we on the verge of the next cosmic revolution? If the evidence from Webb holds, it could mean we're standing on the edge of a new understanding of reality. The idea that there are galaxies from another universe pushes the boundaries of human knowledge and challenges us to confront possibilities we've only imagined in science fiction. As Dr. Martin has said, if there's one thing Webb's discovery teaches us, it's that the universe, or perhaps the multiverse, is far stranger than we could have ever conceived. The data continues to come in, and scientists are eager to explore every facet of what Webb's findings imply for the fabric of reality. The journey is only beginning, and it's one that promises to reshape our understanding of the universe in unprecedented ways. For now, though, the cosmic mystery endures, leaving us to wonder about the true nature of the galaxies Webb has uncovered and what they mean for our place in the cosmos.